The horizontal lines of the elements are called as the rows and the vertical lines of elements are called as the columns. Column matrix. Column matrix means a matrix having only one column is called a column matrix. If all the non-diagonal elements are zeros, if all the non-diagonal elements are zeros, then it is called a diagonal matrix. See? Hello dear students, welcome to this session of Discrete Mathematics class. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. So in this session, I am going to discuss very easiest and a simple topic, that is matrices. So here in this session, I am going to discuss regarding the matrices, definition of matrices and types of matrices and the operations on matrices. Now let us come to a matrix first. This very simple concept and very important for the point of examination. What is a matrix? As you might have been studied this in your previous classes itself. The rectangular arrangement, the rectangular array of elements in rows and columns. The rectangular arrangement of elements in rows and columns is called a matrix. The horizontal lines are called the rows and the vertical lines are called as the columns. So the rectangular arrangement of elements in rows and columns is called a matrix. So these are called the rows. This 1, 5, minus 9 is row, 2, 4, 5 is also a row. So 1, 2, first column, second column and third column. Such an arrangement of elements. So the rectangular arrangement of elements in rows and columns is called a matrix. So this is called the first row. These are called as rows. First row and second row. And these are called as the columns. So this is called first column, second column and third column. First column, second column and third column. These are called as the columns of a matrix. So such an rectangular arrangement of elements in rows and columns is called as a matrix. So here also this is a matrix. This is first row, second row and third row. These are called as the rows. The horizontal lines are called as rows and these are called as the column. First column, second column and third column. These are called as the columns of a matrix. So here the horizontal lines of the elements are called as the rows and the vertical lines of elements are called as the columns. Let us take one more example. If A is equal to, let me write 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a matrix. This is called first row and this is called second row and whereas this is called as the third row. These are called as the rows and these are called as the column. First column, second column and third column. First column, second column and third columns. These are called the columns of the matrix. So horizontal represents the horizontal elements will represent the rows and vertical elements will represent the column of a matrix. Now this is the definition of a matrix. So the rectangular arrangement of elements in rows and columns is called as a matrix. So usually a matrix is represented by a big bracket or even we can also represent between the two small brackets like this. This is also a representation of a matrix. Now let us come to the next, the order of a matrix. Order of a matrix is defined as the number of rows into number of columns. Rows into columns, the number of rows. Order of a matrix is number of rows into number of columns will give the order. So the order of a matrix, order is always equal to number of rows into number of columns. The number of rows into number of columns will give the order of a matrix. Let us consider, for example, here how many rows are there? First row, second row, third row. That is 3 rows. This is first row, second row and third row, 3 rows. And how many columns? First column, second column, first column, second column. So the order is equal to 3 into 2, 3 rows and 2 columns. Now if you come to this matrix, here it contains 2 rows and 2 columns, 2 rows and 2 columns. First row, first column, second row, second column. So here actually the order of the elements will determine the number of elements present in the matrix. This is 3 into 2, it contains 6 elements. This is 2 into 2, it contains 4 elements. So in general, the order of a matrix is denoted as number of rows into number of columns will give the order of a matrix. Now in general, if a matrix of order m into n, a matrix of order m cross n is nothing but a matrix of order m rows and n columns is denoted as, in general, a matrix of order m rows and n columns is denoted as A11, A12, A13, etc., A1n, A21, A22, A23, A2n, A31, A32, A33, A3n, etc., AM1, AM2, AM3. So this is how we are going to represent a matrix. Now, in general, a matrix of order m cross n is denoted as, if A is a matrix of order m rows n column, A11, A12, etc., A1n, again A21, A22, etc., A2 times n, etc., AM1, AM2, the last element is AMN. This is a matrix of order m rows, first row, second row, third row, m rows, and number of columns 1, 2, 3, 4, n columns. So, this contains m rows and n column. This is the representation of a matrix, m rows and n column. Now, let us come to the types of matrices. Very, very important types of matrices. Depending upon the order, let us come to the types of matrices. Types of matrices. So, in types of matrices, the first one is a row matrix. Row matrix means a matrix having only one row is called a row matrix. A matrix having only one row is called a row matrix. For example, A is equal to 1, 2, 3 is an example for a row matrix of order 1 into 3. This is also an example for a row matrix of order 1 into 2. So, this contains one row and 2 columns. This contains 1 row and 3 columns. Let us take one more example. If C is equal to 3, 4, 5, 6, 7, this is also a row matrix of order. It contains one row, 1, 2, 3, 4, 5 elements. And similarly, let us take one more matrix, 2, 4, 6, 7. This is also a row matrix which contains only one row and number of columns are 4, 1 into 4. So, in general, a matrix having only one row is called as a row matrix. Now, let us come to the next one, column matrix. Second one is column matrix. Column matrix means a matrix having only one column is called a column matrix. Now, a column matrix, a matrix having only one column is called as a column matrix. That's all, it will have only one column. So, this is an example for a column matrix. Let A is equal to A, B, C is a column matrix of order 3 rows, 1 column. And this is also an example for a column matrix of order 3 rows, 1 column, 1, 2, 3 rows, 1 column. This is a matrix of order 2 into 1. Similarly, if you want one more example, D is equal to 1, 2, 4, 5, 6. This is also an example for a column matrix of order 1, 2, 3, 4, 5 rows and 1 column. So, in general, a matrix having only one row is called row matrix. A matrix having only one column is called as a column matrix. Hope you followed. Now, let us come to the next one is the square matrix. Square matrix. Square means equal. If the number of rows is equal to number of columns. In a matrix, if number of rows is equal to number of columns, then it is called as a square matrix. So, a matrix in which the number of rows is equal to number of columns is called a square matrix. Usually, a square matrix is of order 2 rows 2 column, 3 rows 3 column, 4 rows 4 column, m cross m or n cross n. So, let us consider an example. This is a matrix of order 3 rows 3 column, therefore, this is a square matrix. So, a matrix having number of rows and number of columns are same. A matrix in which the number of rows is equal to number of columns is called a square matrix. 3 rows 3 column. This is also an example for a square matrix of order 2 rows 2 column. This is a square matrix of order 1 cross 1. It's a just an element, an entry. So, 1 cross 1, 2 comma 2, 2 cross 2, 3 cross 3, they all comes under a square matrices of order 3 rows, 3, 2 and 1. So, these are all example for square matrices of order 3, 2 and 1. Now, let us come to a very important concept. In a square matrix, if let us consider a square matrix, A is equal to 1, 3, 4, 5, 2, 6, 7, 8, 9. The elements from left top corner to the right bottom corner, these elements 1, 2, 9 are called as the principal diagonal elements. Diagonal elements, they are called as the principal diagonal elements. So, in the above example, 1, 2, 9 are called the principal diagonal elements, and these 2, 7, 4 are called as the secondary diagonal elements. They are called as the secondary diagonal elements. So, the elements from left top corner to the right bottom corner are called principal diagonal elements, and similarly, the elements from left bottom corner to the right top corner are called as the secondary diagonal elements. So, here 1, 2, 9 are the principal diagonal elements. Clearly, if you come to this example, here in this example 3, 1, 1 are the principal diagonal elements. If you come to this problem, here 2 and 1 are the principal diagonal elements. Okay, right. Now, knowing this, let us come to the very important definition, that is a diagonal matrix. Diagonal matrix. Diagonal matrix means, first of all, it is a square matrix. A square matrix means number of rows is equal to number of columns. A square matrix is said to be diagonal matrix if all the non-diagonal elements are zeros. If all the non-diagonal elements are zeros, then it is called a diagonal matrix. See, 2 0 0 0 4 0 0 0 5 is an example for a diagonal matrix. So all the non-diagonal elements are 0 except diagonal elements, all elements are 0. This is an example for a diagonal matrix of order 3. So all the elements are 0 except the principal diagonal elements is called a diagonal matrix. Let us take one more example for a diagonal matrix. A is equal to 2 0 0 0 4 0 0 0 5. This is also an example for a diagonal matrix. So one more example, 1 0 0 5. This is also an example for a diagonal matrix of order 2 rows 2 column, and this is 3 rows 3 column. So in general, a diagonal matrix is a square matrix in which all the non-diagonal elements are 0. So non-diagonal elements are 0. That means all elements are 0 except the principal diagonal elements. Now let us come to the very important, in the examination they may ask this for 2 marks. 2 marks definition, they may ask, define a scalar matrix. Scalar matrix. So a scalar matrix is a diagonal matrix in which all the diagonal elements are same. A diagonal matrix is said to be a scalar matrix if its diagonal elements are equal. If all the principal diagonal elements are same in a diagonal matrix, then it is called a scalar matrix. For example, A is equal to 5 0 0 5 is a scalar matrix of order 2 rows 2 column. Another example, 3 0 0 0 3 0 0 0 3 is an example for a scalar matrix of order 3 rows and 3 column. Let us take one more example. If C is equal to 2 0 0 0 2 0 0 0 2, this is also an example for a scalar matrix of order 3 rows 3 columns. So it's a diagonal matrix in which all the diagonal elements are same, right? A diagonal matrix is said to be a scalar matrix if all the diagonal elements are same, principal diagonal elements are same, then it is called a scalar matrix. So these are example for scalar matrices of order 2 rows 2 column and 3 rows 3 column, 2 into 2, 3 into 3, that is 2 and 3. Now next one is an identity matrix or unit matrix. Identity means 1. So a square matrix in which all the principal diagonal elements are equal to 1 and other elements are zeros is denoted as I, is called an identity matrix. So let us take an example. I is equal to 1 0 0 1 is a 2 rows 2 column identity matrix. 1 0 0 0 1 0 0 0 1 is also an identity matrix of order 3 rows and 3 column. That means this identity matrix is also an example for a scalar matrix as well as diagonal matrix. Okay. So identity matrix is a scalar matrix in which all the scalar elements are equal to 1. It is a square matrix in which all the non-diagonal elements are zeros and the diagonal elements are equal to 1. So very simple definition is a square matrix in which all the principal diagonal elements are equal to 1 and other elements are zeros. This is also an example for a scalar matrix. So all elements are 0 except the principal diagonal elements, and all the elements are 0 except the principal diagonal elements, and the principal diagonal elements must be equal to 1. That is called as an identity matrix. So all identity matrices are example for scalar matrices, but all scalar matrices are not identity matrices. So this is regarding the identity matrix. Now next one is zero matrix or a null matrix. So null matrix or zero matrix. Null or zero means a matrix in which all the elements are 0 irrespective of their order. So a matrix in which all the elements are 0 is called a null matrix or a zero matrix, and it is denoted as 0. So A is equal to 0. This is a null matrix of order 1 row 1 column. This is a null matrix of order 2 rows 2 columns, 0 0 0 0. This is also a null matrix of order 2 rows and 3 column. So these are example for null matrices of order 1 cross 1, 2 cross 2 and 2 cross 3. Suppose if you want 3 rows, 3 column, this is also an example for a null matrix of order 3 rows and 3 column. So denoted as WO, null matrix, 0. Okay. So a matrix in which all the elements are zeros is called a null matrix or a zero matrix, empty matrix or void matrix. Now, so these are all the definitions, these are all different types of matrices. Now, by knowing these types of matrices, let us know regarding the equality of matrices. So, equality of matrices, two matrices A and B are said to be equal. Two matrices A is equal to Aij and B is equal to Bij are said to be equal if they are of same order and the corresponding elements are also same. If Aij is equal to Bij for all I and j, for all the values of I and j, then the two matrices are said to be equal and it is denoted as A is equal to B. Two matrices are said to be equal if and only if they are of same order and the corresponding elements are also same. If the matrix A of Ij is equal to B of Ij, if Aij is equal to Bij, then the matrix A and B are said to be equal. Now, let us take for example, if A is equal to 2, 3, 4, 5, another matrix B is equal to 2, 3, 4, 5, these two matrices are said to be equal, these are equal and it is denoted as A is equal to B. Because the order of A, this is of order 2 rows 2 column, this is also of order 2 rows 2 column and the number of and the elements are also same 2, 3, 2, 3, 4, 5, 4, 5. Now, let us take one more example. If A is equal to x 1 3 y and B is equal to 2 1 3 5, these two matrices are equal if and only if the value of x is equal to 2 and the value of y is equal to 5. These two matrices are equal if and only if x is equal to 2 and y is equal to 5. These are called the equality of matrices. In case of 3 rows, in case of 3 rows 3 column matrix, if A is equal to 1 2 3 4 5 6 1 0 1, another matrix B is also of same elements 1 2 3 4 5 6 1 0 1, then these two matrices are said to be equal because they are of order 3 rows 3 column and the corresponding elements are also same. Okay. This is how we are going to define the equal matrices. Two matrices are said to be equal, that is called equality of matrices. Two matrices are said to be equal if and only if they are of same order and the corresponding elements are also same. Let us take a small problem based on this. Find x, y, z from the following equation. So, what is required to find is x, y, z. What is given? Matrix x plus y plus z, x plus z, y plus z is equal to 9, 5 and 7. By equality of matrices, let us equate it. X plus y plus z is equal to 9. Let us represent this as equation number 1 and x plus z is equal to 5, equation number 2, and y plus z is equal to 7, equation number 3. Now, there are 3 equations. Solve these 3 equations, you will get the value of x, y and z. Now, from this, what is here? From 2, x plus z. So, you just keep this y as it is, x plus z can be written as 5. So, y plus 5 is equal to 9, y is equal to 9 minus 5, y is equal to 9 minus 5 is 4. Okay. Now, from these two equations, from equation number 3, what is equation number 3? Y plus z is equal to 7. Just substitute the value of y. Z is equal to 7 minus y. 7 minus, what is y? 4. 7 minus 4 is 3. So, z is equal to 3. The value of z is 3. Y is 4, z is 3. Now, from this equation, let us come this equation. From equation number 2, what we have? X plus z is equal to 5. What is required to find is x is equal to 5 minus z. 5 minus, what is z is 3. 5 minus 3 is 2. So, x is equal to 2. Now, what is say from this? Therefore, the value of x, y, z, x is equal to 2, y is equal to 3 and z is equal to 4. This is the solution. If you verify, just add for verification x plus y plus z. If you want to verify, x plus y plus z is equal to, what is x? 2. What is y? 3. What is z? 4. What is this equal? 4 plus 3, 7. 7 plus 2 is 9. x plus y plus z, 9 is equal to 9. That's it. This is how we are going to solve the problem. So, hope you followed this. So, these are the basics. The chapter itself is the basics. So, these are all the basics concepts of a matrices. Type, definition of a matrix, then types of matrices, equality of a matrices. So, that's all regarding this session. Let us meet with different concepts in the next session. So, in the next session, I am going to take operations on matrices, very important section. Just attend the class. That's all regarding today's session. Let us meet with different concept in the next class. Thank you very much.